Hey guys, it's IDW and welcome back today. And we're finally going to be finishing off this carry look everywhere adder. So off camera, as you can see, I finished off the carry and I made these wires right here, which are just ORing all these guys together. Because the way that carry look everywhere edition works, is it's sort of like this redstone dust at the bottom, since it's the NAND of the two inputs. That's sort of like where the carry is coming from. And then these torches basically power it, so even if this was off, it couldn't come onto this one. It couldn't move over to a higher bit value unless this torch also was off. So yeah, that's basically how Carry Look Everywhere edition works. And since it slabs, the values from higher levels can't actually affect the bottom ones. You see, if we break this, then that signal can't flow down there. We get a output. So yeah, that's basically how Carry Look Everywhere edition works. I'm sorry if my previous explanations were a bit more confusing, but it's much easier to see once you actually see one of these things in use. So now we're going to build the second XNOR, because we have our carry data right here, and we have our first XOR right here. This first XNOR, sorry. So the way that we're going to do this is we're going to, first of all, we're going to make a NOR gate. And since it's got both of the inputs with repeaters, that's going to take 2 ticks. So we can make a 2-tick AND gate, and it's going to be synced. So yeah, that's exactly what we're going to do. Just going to bring that like that. And we're going to put a torch there, and then this torch is going to power this block, and then that's also going to power that. So basically, this torch is the inverse of this, and it's powering this. And this torch right here is powering this, which is powering this, and it's the inverse of this. So yeah, that's an AND gate. So then if we bring this up right here, ta-da! XNOR, because we have all the inputs that we need. And if we just turn it out like that, then we can have it coming out of the actual ladder. So yeah, that's our second XNOR build. Really simple, right? So now I'm just going to have to stack this thing now, which may take a little bit, but yeah, that's basically the final part of this done, and this video is going to be really short. It's pretty much just going to be this clip right here and me actually showing that it works as an adder. Sorry if this wasn't the most thorough explanation of Carry Look Everywhere edition, but yeah. You know what? I can just build this on camera, you know. Yeah, sure. Why not? Because it's that simple, literally. Now you might be wondering, why do we have 3 bits? And actually, we have another bit, and that's the carry out. That should be right there. So yeah, this is right here is the carry out, but you might be wondering still, why do we only have 4 bits? And the answer is this isn't actually the least significant bit. This is just the XNOR of the carry and the first carry and the second bit. The sum that we have down here is actually the result of our first bit if we're not using a carry-in. If we are using a carry-in, then all you would do is you would just extend these guys out one more and make another tower, and then you have the generate signal be your carry-in, at least the inverse of it. But yeah, take you down, and since it's an XNOR, we'll have to invert it to make it into an XOR, because basically because an XNOR won't give the sum, an XOR will. And the only reason that you can use it in an adder is because if you string two of them together, then it will act the same way as two XORs will. But yeah, this is our carry look everywhere adder finished. Yeah. So, does this thing really actually add? Well, first of all, let's do 11 plus 1. Which just looks like this. It's 1, 0, 1, 1 plus 0, 0, 0, 1. If you ever want to know what it is to test your adder. And sure enough, we're getting a result of 12, which is 1, 1, 0, 0. I don't think I've ever really gone over that, but yeah, I just assumed you guys would do the math in your head to figure out which one is which. But yeah, that's Carry Look Everywhere edition. And perfectly synchronized. This is a 4-tick adder, and it's really, 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 really nice. So yeah, and thus concludes this entire series on adders. Yeah, I know. It's over. It's all over. And so basically, you should be able to move up to my pipelining series at this point. You should have enough knowledge just from this series. That finished a while ago, but I was sort of doing it at the same time as this series. So, yeah. Anything else that I want to say? Oh yes, I do plan to make a subtraction series after this, which is sort of like another basis thing that's sort of based off of this series. But yeah, see you guys around.